Hey everyone, Mr. Voikin here, and we are in the electronics unit, and we're going to take a look at breadboarding. Now in class we will be breadboarding our circuits on an actual breadboard and using actual components and wires and power supplies, but for this demonstration I'm going to be using a cloud-based application made by Autodesk called Tinkercad. And the reason I'm doing it here is that in class it's very difficult to see the demonstration clearly, as the parts are very tiny and my hands are very big and everything seems to get in the way and students are unable to see. What you're going to want to do if you actually want to practice your circuits at home is sign up for a Tinkercad account at tinkercad.com. And once you are signed in, you will go to the welcome window as you see on the left side of the screen here. It defaults usually to the 3D designs page, but all we have to do is click on circuits and then create new circuit. Okay, and that's going to open up our circuit workspace here. And if you notice over on the right hand side, it says components basic. That only provides us with the essential few components, but I always just go here to the all, and that allows me to use everything that is available. Now on the right side of the screen you see a schematic drawing. There's two circuits on this drawing. One on the right is sort of half hidden. We'll get to that later, but for now the one on the left is the one we're going to focus on, and this is a series circuit with one resistor and 3 LEDs connected to ground and V+. So in order to breadboard this, we need to know what the components are, what the symbols are, and what the components look like, and we need to know where to place them on the board. So to begin, let's scroll down here and we'll go find a breadboard. So here's a breadboard, and we'll put that into the middle of the screen. Okay, now on the breadboard, if you look right here, you'll notice that there is a negative sign. It's a little blue negative sign, and all those green dots that are covered right there are all connected underneath. So the ground rail is connected side to side right there. So those first 5 holes are connected to the next 5 holes and the next 5 holes. So if I was to go up to the top, change the wire color to black, as black represents ground, and I was to run a wire from here down to there, the holes that it's covering are all connected together underneath with a small metal clip, so a conducting metal clip. Now if we notice on the top of the breadboard, we've got those same holes giving us a top ground rail and a bottom ground rail. Now on the schematic drawing, if we look over to the left, that is going to be the ground right down there, which is symbolized by that upside down T. Okay, well, what about the one at the top, which is the arrow that's pointing upwards, and it says positive 12 volts beside it? Well, that is the positive rail, and positive is represented by the color red, and it would be these 25 holes right here and these 25 holes right there. Okay. Now essentially the board is sometimes split into 4 little sections. You have this section up here on the top left, then the bottom left, and we've got the bottom right and the top right. Notice that the gap right here is a lot bigger than these other gaps going between in here, which indicates that those are not connected. So in order for me to connect the left and right sides of the boards, what I want to do is put a jumper in there. Okay, so I'm going to, oops, sorry. I'll just move this back. I'm going to create a small little red jumper going from here to here, and another one from here to here. And to connect the bottom of the board to the top of the board, I would go from here to there. So essentially, now that I've put those jumpers in there, every one of those holes that are covered by the red wire are connected together. Now for the ground rail, we go to black, and again we would need to put a jumper right there, a jumper right there, and a jumper between here and here. And now essentially every one of these holes and every one of these holes are connected as well. So now we have our ground rails and our positive V plus rails all connected. So what about these holes on the middle of the board? Well, those ones, and I'll just use a green wire for now, are connected going straight up. So those 5 holes are connected. These 5 holes are connected, these 5, and so on and so on. However, these bottom 5 are not connected to the top 5, and not connected to these 5, and not connected to these 5, and these ones are not connected side to side, only up and down. Okay, so I'm just going to delete all these because they're unnecessary to build the circuit. And let's take a look over at the schematic drawing at our first component, and we can see that that is a resistor right there. Now what it says, we need to calculate the resistance, and that is using Ohm's law. So what we want to do is we want to take the voltage supplied, subtract our voltage drop, and divide that by the current, which is going to be 0.03 amps. So what is our voltage supply? Well, that is 12 volts. And what is our voltage drop? Well, a red LED drops 1.8 volts, an orange LED drops 2.0 volts, and a green LED drops 3.5 volts. So total together we have 7.3 volts that we're going to lose as a voltage drop. So 12 volts minus the 7.3 volts divided by the 0.03 amps, which is the amount of current that we want in the circuit. And that will give us our resistor value. So when I punch that into the calculator, I get 12 minus 7.3 and divide that by 0.03. It tells us that we have a resistance value of 156.7 ohms. And now I would want to use the first resistor value that is greater than that, which would be 180 R. So I'm going to go grab a resistor here on the left hand side, which I believe is up near the top, and there's the resistor. And notice that where is it connected to in our drawing? Well, it is connected down to ground. So I'm going to take this resistor and I'm going to put it down to ground. Now before I do that, I'm actually going to have to delete all of these other lines that were put in there. Just give me 1 second. Okay, and we'll take the resistor and we'll pop it down to ground. Okay, now what value of resistor is that? Well, it's 180 ohms. So at the top here it says we can change this to ohms and type in 180, and notice that the color band will change to a brown, gray brown, symbolizing a 180R resistor. So now that resistor is in, and what is it connected to? Okay, well, the other side of the resistor, as we can see, is connected to the negative side of this LED right here. So I need to go find an LED, which is right here. And on this LED, it's got two legs. The straight leg is the short one, and the bent one is the long one. The short leg is negative, and on the schematic diagram, the line is negative. So the other half of that resistor, the other lead on the resistor, is connected to the negative lead on the LED. So I'm going to go place this right there. Now it says it's a red LED, and that is a red LED, and that connection is made. And you can see right here the anode, which is the positive leg, is now off to the right hand side. It's not in the same 5 holes that the resistor and the LED are connected to, otherwise it would be connected to itself. So we need to look back to our schematic drawing and look at the anode side or the positive side. What is it connected to? Well, if we follow it up, it goes to another LED, in this case an orange LED on the cathode or the negative leg. So I'm going to go grab another LED, and essentially I will put it right here. Now I could put it there and sort of stack them on top of each other, but you're not going to be able to see the leg behind it. So I'm just going to put it right off to the right here, which means that those legs are not connected right there. Even though they're sort of side to side, remember these holes are not connected side to side, only up and down. So I'll go grab a jumper wire, and I'll use a blue one, and I'll go from here to there. And now the positive leg on this LED is connected to the negative leg on this LED, and I'm just going to select the LED, and we will change that to an orange color. Okay, now you can see that off to the right is the anode again, which is connected to nothing, but on our schematic drawing it is. So what is it connected to? It's connected up to the third LED, which is a green LED, again on the negative leg, which is the cathode. So I need to go grab one more LED, and again first I'll switch that to green, and then I'll grab a blue wire again, connect the positive leg to the negative leg, and essentially what we have on the breadboard is exactly the same as what we have on the schematic drawing. Now we have one final connection to make, and that is to take the positive leg of the green LED up to the positive rail. So any wire that is connected up to the positive rail should be red in color, so I'll switch that to red, and I will just swing this up and over to the positive rail there. And that completes the circuit, and the only thing we need to do now is bring in some power. So I need to go find a battery. There's a 9-volt battery right there, so I'll bring that in, and I can press R to rotate it and zoom out, and I'll put that right there and bring this down to there. And now I'm going to grab a red wire off of here, sort of bring it up and over to positive. You can straighten those out, and I'll go grab a black wire and bring it from the negative side of the battery down to the ground rail. Now this wire turned black for some reason. We'll switch back to red, proper color coding, and this guy will just make it look pretty by straightening everything out. And now I'm connected to a 9-volt battery, and all the wiring looks correct, and all that's left to do is come up to the top and press start simulation, and yay, all the LEDs lit up. meaning that our circuit is properly connected and done. Well, I will end the video here as we are finished constructing the series circuit for resistors and LEDs. And next video we will look at the parallel circuit.